Okay, we've got a more complicated trig equation here, and first impressions are really important. So what leaps out at you when you look at this? Well, this sine squared may leap out at you at being some squaredy trig, and in fact your first reaction might be to turn that into 1 minus cos squared, and that would be a good thing to do actually. Okay, but let's look at the bigger picture. What we've got is brackets, okay, and you may still be thinking that when you have a bracket times a bracket, the good thing to do would be to multiply them out. But I want you to look at this as being a bracket times a bracket equal to naught. We have a factorized expression equal to naught, okay? And if you've thought about factorization properly, you know that an equation that's in that form leads instantly to two possibilities. So we've got bracket times bracket equals naught. So my possibilities are 2 sine x plus 1 equals naught. And the other possibility is 3 sine squared x minus cos x equals naught. So instead of having one horrible equation, actually this splits immediately into two simple ones. This first one, sine x, would have to equal minus a half, so I'm going to have some solutions to that. And then this one here, I'm going to get solutions to this. This is going to need more work. Okay, so let's label them 1 and 2, and let's leave 2 for later. And find the solutions to 1. So I'm going to have a first x, and I'm going to have a second x. And of course my first x is just going to be an arc sine of minus a half. Okay, we are of course in radians, so you make sure you calculate it in radians if you have to use your calculator, which will give you minus pi by 6. And the second x, well, for a sine we do pi take away the first x. So that is going to be 7 pi by 6, okay? And at some point I'm going to have to consider solutions in the correct range. So this one's okay. This one I'm going to need to add 2 pi to, all right? But I'll deal with those when we come to the final set of solutions. And then I'm going to move on and solve equation 2. And equation 2 was this one here. So instead of just copying the equation out, I'll think about what I'm going to do. I've got a mixture of a sine term and a cos term, and the sine one is squared. So I can turn the sine squared x into 1 minus cos squared x. But I'm going to use the letter c to mean cos x to make this look cleaner. So I'm going to have 3 times sine squared x is 1 minus cos squared x, which I can write as 1 minus c squared, using c to mean cos x. And of course minus cos x is just going to be minus c equals 0. And this is now looking very much like a quadratic equation. Multiply it out. Okay, I'm going to get minus 3c squared plus 3 minus c equals 0. So minus 3c squared minus c plus 3 equals 0. You could have got 0 on the other side if you didn't like those minus signs. This is not a particularly nice quadratic equation. It's going to have some horrible decimal solutions. You can record them in the exact surd form. I've chosen to give them as decimals. Now, I can see that the second one, remember, cos x is a graph that only goes up to 1 and down to minus 1. The cos x graph looks like this. So it's impossible to have a cos equaling minus 1 point something. Okay, that's too far down. So this is a correct solution to your quadratic, but it's actually not going to lead to any angles because it can't be the cos of anything. So what you do in this case is you must record that you found the solution, but you just lightly cross it out to show that it doesn't lead to any correct answers for the angle. So all we've got to solve in terms of doing a cos equation is to say that cos x equals this 0.84713. I've chosen to put it in decimals. I need to have considerably more than the 3 significant figures that I want to be correct in my answer. If I rounded this to 3 significant figures, then I've got no guarantee my answer will be correct to 3 significant figures. So I need a couple of extra decimal places. Okay, so for this I'm going to get a first x, and I'm going to get a second x, and my first x is just going to be arc cos of that value, and my second x is going to be, for cos it's always 2 pi minus the first value. So it works out like this. Okay, we've got these two answers. Now both of those are correctly in this interval, and their 2 pi repeats would skip out of that interval because we'd go less than 0 or we'd go more than 2 pi. So these are 2 of my answers, okay? So I need to record these. Final answers should be to 3 significant figures, and I've also got these 2 previous ones. Now, it says 3 significant figures, but wherever possible give exact values. So I'm going to, I think, leave them in terms of pi. If this was an exam, I think I would be tempted to go with the 3 significant figures, but if it says 3 significant figures, that's what you should go with. So my minus pi by 6, when I add 2 pi to it, is going to be, what's that going to be, 11 pi by 6, and we've already got, by 6, and we've already got 7 pi by 6, and we've got 0.56024, so that's 0.560, and 5.72. Those I will give to 3 significant figures. Double underline everything, and we are done. So the key point, very near the beginning of this question, was to recognise that when you've got the gift of a bracket times a bracket equaling 0, don't even think about multiplying it out, turn it into 2 simpler equations.